In this video, we will look at how to determine the number of angular nodes and radial nodes in a given electron orbital. Let's remember that our principal quantum number n is related to the numerical value to the left in our electron orbital, and that our angular momentum is related to the letter. In this case, L would be 0 for an s orbital. We can calculate the number of radial nodes by remembering that the number is equal to n minus L minus 1. This will give us a numerical value. Our number of angular nodes is simply equal to the numerical value of L. So let's look at our first example. For the 1s orbital, we know we have a principal quantum number of 1, and we have an angular momentum of 0, indicating the s orbital. That means that we can calculate the number of radial nodes as 1 minus 0 minus 1, which would be equal to 0. The number of angular nodes would just be equal to 0, so we can fill that in. So for a 1s orbital, we would have 0 radial nodes and 0 angular nodes. Next, let's look at the 3pz orbital. Here, our principal quantum number will be 3, and our angular momentum number will be 1 for the p orbital. Let's calculate the number of radial nodes. We've got n equals 3 minus L equals 1 minus 1, which will give us 1 radial node. We also have 1 angular node since our angular momentum is 1. Our next electron orbital is the 4d xy orbital. Here we have an n value of 4, and for the d orbital, our L value will be 2. We can calculate our number of radial nodes. That would be 4 minus 2 minus 1, giving us a total of 1 radial node, and a total of 2 angular nodes based on our L value. Our last electron orbital is the 6px orbital. This has an n value of 6, an L value of 1 for the p orbital. We can calculate the number of radial nodes as 6 minus 1 minus 1, which would give us 4 radial nodes, and again, 1 angular node. In this way, we can calculate the number of radial nodes and angular nodes for any electron orbital.